Hello everybody, my name is Robert Gerdung, and for my project I have gone with the implementation project to create a hybrid cryptographic scheme where I used RSA and Blowfish. RSA was covered in class, Blowfish was not. This PowerPoint will cover how to encrypt and decrypt using RSA and Blowfish, and I will go over some of the code architecture that is in my project. After the PowerPoint ends, I will open up my project and I will show you a demo of what it's doing, and you can see that it works. Okay, I will leave a timestamp for when the demo starts, so you can just skip the PowerPoint if you please. So, for a hybrid cryptographic scheme, we will start by generating Bob's public key using RSA, and then the user will create a private key. The user then creates a message which will be encrypted with Blowfish, and we can compute the key cipher that will be sent to Bob. Once Bob receives a key cipher, he can decrypt it using RSA and then use the recovered key to decrypt the message using Blowfish. So, for RSA's key generation, we will generate two large prime numbers of equal size, denoted as P and Q. We will compute n, which is equal to P times Q, and our totient, which is equal to P minus 1 times Q minus 1. We will then select a random number e such that GCD of e and our totient is equal to 1, and our common, we need to compute another integer d such that e times d is congruent to 1 mod our totient. These have a size requirement as well. E and d must be strictly smaller than our totient but greater than 1. From there, all that needs to be done is we need to display our public key, which is n and e, and we will keep d private. For RSA encryption decryption, we will encrypt our message by first obtaining the public key, and then we will create a message which is smaller than n. We will compute our ciphertext by taking our message to the power of e mod n, and then we will send the ciphertext to the other party. To decrypt it, we will take the ciphertext to the power of our private key and mod n. Blowfish encryption will Blowfish is a encryption algorithm which is a 64-bit block cipher. So we will need plain text of 64-bit block, and we will need a p-box array which contains 32-bit integers, and these typically contain at least 18 values. My project used 36. We'll use 4 S-box arrays which contain 32-bit integers as well, and each S-box must contain 256 values. Our P-box and S-box arrays are initialized with 32-bit values of pi, and we will need a key from the user. So to start with encryption, we will divide our input P into 2 equal halves of 32 bits, and we will XOR the left 32 bits with the first P-box value, and that will be the output of our right side of our ciphertext. We will then divide the XORed output into 4 equal 8-bit pieces, denoted as A, B, C, and D. And we will use each 8-bit piece as input for our S-box to retrieve a 32-bit value from the array, where A will go into S-box 0, B will go to S-box 1, and so on and so forth. We will take the output of S-box 0 and S-box 1 and perform modular addition, where our mod is equal to 2 to the 32. We will then XOR the above result with S-box 2, perform another modular addition with the same mod with the above result with S-box 3, and we will XOR that result with the right side of the plain text. This will be used for the left side of the plain text. So that will happen another 15 times, and then for the final step, we will XOR the right side with K18 with the left side with K17. We will then swap left and right, and the output will be the ciphertext. If that was confusing, which I know it was, you can just see the diagram here, and from there you can make your own conclusions. You can pause the video to study it, or you can go to Wikipedia to study it as well. Blowfish decryption will work the same as encryption, where the only thing that changes is you will start with the last key and work your way to the first. So pbox 18 all the way down to pbox 1 if you're using these standard numbers. So the key schedule for Blowfish starts by first XORing the first 32 bits of the key with pbox 0 and the second 32 bits with pbox 1, and continually going through the key until every pbox value has been replaced. You will then create a 64-bit 0 string, which will then be encrypted using the Blowfish algorithm. You will use the left side of the ciphertext produced from the algorithm as a replacement for pbox 0 and the right side for pbox 1, and you will continue this process until every value of pbox, sbox 0, sbox 1, 2, and 3 are all replaced. This means that if you use the standard 18 values, this will happen approximately 541 times, if I'm not mistaken. So the disadvantages of Blowfish are that the key schedule can take some time because you're replacing a lot of values using Blowfish. So if you replace the key very frequently, it might not be a good idea, especially if the processing power is very low, where it takes a long time to do this. 64-bit input sizes can be vulnerable to birthday attacks. So since this has been discovered, the creator of Blowfish has recommended that everybody move to 2Fish. Now, the key size in Blowfish is usually between 32 bits and 448 bits. For my project, I have doubled the rounds used in Blowfish, and I increased the size of the pbox as well to 36 bits or 36 values to accommodate my key size of 512 bits. Increasing the size of the sbox will allow the key to be rotated and XORed with the entire sbox, and increasing the number of rounds will allow us to use the entire sbox for our encryption. So, code architecture. The numbers are stored with the integer class from the CryptoPP library, just standard. Our prime numbers, P and Q, are of size 256 bits, so we get a 512-bit integer, and these are generated with the CryptoPP library, so I did not do a primality test to check that these are prime, as this is going to return a prime number every time. Our multiplicative inverse is calculated using the extended Euclidean algorithm, and our key is input in ASCII and then converted to binary. Keys that are greater than 64 characters or 512 bits will be reduced to the first 64 characters, and keys smaller will be padded with ASCII zeros and then converted to binary. The binary will then be converted to an integer to be used for RSA. We will display all of Bob's variables in this case, as this is a educational project, and if I was to step forward and create this for use among friends or something, obviously not everybody would be able to see Bob's variables, and I'd have to break it up into generating, encryption, decryption, stuff like that. So for our code architecture continued, we will increase this the rounds of pbox to allow for a 512-bit key, and our plaintext message will be converted to a string of binary. If the plaintext is less than 64 bits, at any case, it will be padded with zeros, and then that will also be encrypted. For our sbox, the 8-bit string is converted to an integer to select the value between 0 and 255, because the most you can represent in 8 bits is 255, which is why our sboxes contain that many values. So our ciphertext is going to be kept as a binary string, and the reason that our ciphertext is going to stay as a binary string is because in C++ ASCII is represented from 0 to 127, so I cannot actually convert it into ASCII and use that converted ASCII as our ciphertext. I need to figure out a way to convert that back to a character string. However, binary string works just fine, so that is what I will use. Our architecture also will reset the values of pbox, our S boxes, and this is just to prove that the number that we retrieve from RSA will actually generate what we want. Decrypting the message, we will recover the key input from the key schedule for Blowfish and our ciphertext input into Blowfish algorithm with keys in reverse order. So that is our decryption process. One decrypted message will be converted back into ASCII. So the input will be exactly the same as our output, which is exactly what we're hoping for. So we've reached the end of the PowerPoint, so I will pull up my project and we can go through a couple of demos. Put this in full screen. So CryptoPP very fast, generated all of our public variables very quickly, and I'm sorry, these are all the variables that we used, and this is our public key. D right here will be kept private, as we've discussed earlier. So now we're playing the part of Alice where we want to create a message to be used to decrypt. So we're going to say that this is our key, and then we have generated a key. Now we're going through the key schedule for Blowfish to encrypt our message, and our message is going to be, this is a message, as this is indeed a message. Very quick already. Our ciphertext has already been created, and now Bob is going to decrypt our message with the cipher key that we have generated. It takes a little bit. It's a big number. So should be any second now. Once he's decrypted the message for the key, then our ciphertext will be generated into an actual plaintext message. So here we go. We can see this. Bob's decryption is here. We've recovered this key, which is our key from here. And then we've gone through our key schedule again for Blowfish and decrypted the message. This is our message. This is the ciphertext that we received, and this is what we've decrypted. So we're going to run this again, and we're going to show that I'm actually padding the input with zeros for the key. So right here, if I just leave it blank for the input key, then it will pad it with nothing but straight zeros. And that is the number that you will get every single time. So now we want to create a message. This is also a message. Top kek, bad beef. We're just going to show that this works for generally any size. We just keep going, make it bigger and smaller. So now Bob's description is going again. It's also going to take a couple of seconds. Okay, he's received the key right here. It's the same as the one there. Blowfish key schedule is right there, and then we have decrypted the message. This is also a message, top kek, bad beef. We're going to do this one more time, but with a smaller input. Our input key, again, is going to be small. And we're going to show, again, that that is the same value you'll always get. Input message, A, B, C, D. Small. It's smaller than the 64 bits. We've padded it with zeros, and that is our ciphertext. So now that is our cipher key. Bob is now going to calculate our key and then use the key to decrypt our message using Blowfish again. This works just fine. We have decrypted A, B, C, D. So that'll be the end of the program. Thank you all for watching. I hope you had a great time in this class, just as good as I had.